Hello and welcome to Unacademy. Welcome to another session in our NCERT Fundamental series, where today we bring for you another chapter for the portion of 11th NCERT, and that is the chapter of temperature inversion. Now, here we are going to understand what this temperature inversion is, why it is occurred, and also what are the various classification and categorization of temperature inversion. We are also going to take a look into the impact that temperature inversion usually has. And at the end of it, we shall be taking a look at the mains question which had been asked from the same topic and try to understand how to create answers for the same. Now, before jumping into the topic in itself, an important announcement for all of you. We have launched a special offer for 15-month UPSC subscription for GS plus CSAT plus test series, where you will have unlimited access to all the batches at a special price of 23,999. That offer ends today. So do avail the offer and do ensure that your preparation is on the right track so that you are guided by the mentors of your choice, the educators of your choice, and overall, for the duration of these next 15 months, you get an enlightened view about the portion of civil services preparation. Having said that, now let us take a look at the topic. So here, this topic is in the chapter 9 of the portion of climatology for the fundamentals of physical geography. Now this chapter talks about solar radiation, heat balance and temperature. Now there, NCERT at the end of it has also discussed about temperature inversion, but there it is slightly erroneous in terms of the data pointers and also the text paragraph of it. So that is what we are going to discuss in this particular video, and in detail we are going to understand what is the concept of inversion of temperature. But before that, temperature of air or atmosphere, that indicates a certain pattern. Generally, we have the case that as you move up from the ground surface, there is a decline in temperature. The temperature reduces. Now, why is that the case? So, that is basically because of the basic factor of the various modes of heating that the atmosphere experiences. If we talk about the mode in which the atmosphere receives its heat, so basically, while the popular preconceived notion tells us an idea that solar insolation or the solar rays will heat up the atmosphere directly, but that is not what happens near the ground surface. Near the ground surface, you have a process which is followed, whereby the solar radiation first of all heats the ground surface. And that is because of the basic fundamental that when you consider a mass of air, let's suppose a sample of air, and a solid object. Now you will always find that when heat is applied, let's suppose equal amount of heat is applied to both of these. So the air will always end up indicating a lower rise in temperature. The rise in temperature will be less, whereas in the solid, the rise in temperature will be very substantial because solid is a better conductor than air. So that is why it is the ground surface which gets heated up. Now then the ground surface, by the process of conduction, that is when two different objects are in contact having unequal temperature, that is when the temperature is or the heat is transmitted. So by the process of conduction, the ground surface basically transmits heat to the air immediately above it. And that heat slowly and steadily travels up the atmosphere by the process of convective currents which are generated in the atmosphere. Now here, that also signifies the very important thing that if you are closer to the ground surface, the air will be much more warmer, much more hotter. As you start moving away from the ground surface, the transmission of heat will not be that efficient. That is one of the reasons why you will experience that the temperature starts falling as you go higher up. This is what is also referred to as lapse rate. Lapse rate basically indicating the decrease in temperature or the change in temperature with height. Under normal circumstances, temperature tends to decrease at a rate of around 6.5 degrees Celsius per kilometer under normal circumstances. This is what is also referred to as the normal lapse rate or the environmental lapse rate. Okay, that is what we refer to as the normal lapse rate. Now, why does it happen? Primarily because as you move away from the ground surface, you are moving away from the source of heat. So, source of heat is the heating of the ground. Source of heat is the ground. Now, another important fact why you have lower temperature higher up is because of the fact that as you move higher up in the atmosphere, the density of air particles, they tend to reduce and reduce quite drastically. Density of air particles is maximum closest to the surface and it tends to reduce higher up. Why? Owing to the force of gravity. So, gravity, because of gravity, you have highest density of particles closest to the ground surface. Density of particles closest to the surface. Now, how does that impact the temperature? So, basically, when you consider these particles, air molecules, dust particles, all of them, now they also trap heat and retain heat within themselves. If you will have lesser number of particles, then their ability to trap heat also tends to reduce. So, the natural conclusion from this is that wherever you will have larger number of air particles, dust particles, water vapor, all of them included, there will be a greater trapping of heat. Now, because of gravity, highest density of particles are closest to the surface, including water vapor, including gaseous molecules. That means closest to the ground surface, there will be highest amount of heat which is trapped. So, this is to establish what? That as you move up from the ground surface into the height, the temperature tends to reduce. This is what is also known as the positive lapse rate. Positive lapse rate. Now, due to certain conditions, certain weather phenomena, we experience a condition of negative lapse rate as well. Right? So, under normal conditions, temperature reduces as the height increases. This is classified as positive lapse rate. Now, sometimes what happens is that due to certain weather conditions, as you move higher up, the temperature rather than reducing, it starts to increase. Which means what? Which means that you have colder air here near the surface and you will have warmer air higher up. So, this is a reversal of the normal condition. So, this is what is also known as negative lapse rate. Negative lapse rate. Now, whenever you have the creation of this negative lapse rate, that is what we refer to as the condition of temperature inversion. So, basically, temperature inversion is creation of negative lapse rate. Why does that happen? That is something we will study. Negative lapse rate. So, as you can see, under normal conditions, warmer air is at the bottom and this warmer air, basically on top of it you have cooler and cold air. Warmer air will always have a tendency to rise up. Cooler air will always have a tendency to sink down. So, there is a natural mixing of air which happens, the vertical mixing, due to which the pollutants, all the various different discrepancies in the air, that also gets mixed up. But in the condition of temperature inversion, you have cooler air or cold air at the bottom, then on top of it you have the layer of warmer air, then above it another cold air. So, in this region, will you have mixing of air? No, because cooler air automatically being heavier one will stick closer to the ground surface. Warmer air being the lighter one will always stay on top. So there is not going to be any vertical mixing at all. So this is what is also referred to as the stable air, which is not good. In this condition, when you have stable air, generally cloud formation, precipitation, etc. does not happen. Because for cloud formation, you need the air to rise up. Only then clouds can form. But here the warm air is already at top. It cannot rise further. The colder air is already at bottom. It cannot sink further. So you have stagnant or stable air. There, precipitation, etc. generally doesn't occur. The mixing of air doesn't happen. So if you have pollution, in these conditions, the pollutants tend to remain closer to the surface, and that is where the problems get exaggerated. So here, what is temperature inversion? Reversal of the normal behavior of temperature in troposphere, that is known as temperature inversion. It is quite common but happens for a short duration under general circumstances. Now here, ideal situation for inversion is still air, long winter nights and clear skies. It can happen throughout the year in the polar region. Now, this temperature inversion happens because of various different reasons, and for the various different reasons that it occurs, that is how the classification happens. The classification happens as surface inversion, then you have subsidence inversion, then you have frontal inversion, and also valley inversion. What are these? Let us take a look at them briefly and how they get created. Valley inversion. So, starting with the condition of surface inversion. So, this happens, as the name in itself suggests, because of the surface phenomena. Now, let's suppose you consider any particular place. Let's suppose you consider Chandigarh or Amritsar, those areas which get very cold during winter nights. Now, you consider different conditions, one at 5 p.m., another, let's suppose, at 4 a.m. in the morning. Now, at 5 p.m., if the temperature near the ground surface, let's suppose, is 12 degrees Celsius, the air in contact will also gain 12 degrees Celsius temperature because of the process of transmission of heat. Now then, at an upper elevation, at some random height above, let's suppose the temperature further reduces to 5 degrees Celsius. Further higher up, let's suppose the temperature reduces to 0 degrees Celsius. Now, when we are talking about winter nights, the loss of heat is quite fast, quite rapid. So, during night time, let's suppose the temperature has fallen to, of the ground surface, has fallen to 1 degree Celsius. Now, the air which is in contact with the ground surface, this will also cool down. When you have a very cold object and you touch that object, your hand also becomes very cold by the process of conduction. So, here also, as the surface is very cold, air in contact will also get very, very cold. So, here the air also ends up gaining 1 degree Celsius of temperature. Now, this has lost heat, but at this level, there will be loss of heat, but will it be that substantial? No. First of all, air is not a good conductor of heat, and secondly, it is not in contact with the ground surface. So, let's suppose here also cooling has happened from 5 p.m. to 4 a.m. Let's suppose here also the temperature has dropped from 5 degrees Celsius to 3 degrees Celsius. Above it, it has fallen to, let's suppose, from 0 degrees Celsius to minus 2 degrees Celsius. So, here what do you observe? That the ground surface air is cooler as compared to the air at an elevation. So, this is a condition of what? Of a negative lapse rate. But this negative lapse rate is created why? Because the surface has lost heat, purely a surface phenomena. This is a kind of inversion that we experience in the northern parts of the country, especially during the winter months. So, that is why in these conditions, the air does not mix at all and the air stays in the region where it is. That is why, despite the fact that pollutants and pollution happens in majority of the parts of the northern India throughout the year, the situation or the problem of pollution appears to be much more exaggerated during the winter months. because in these conditions, the vertical mixing of air is absolutely absent. So that is one of the impact of this temperature inversion. Again, next morning when the sun will rise, the ground will get heated up. So the air in contact will also get heated up and normalcy will be restored. But during the night time, as the ground surface again loses heat, only the air in contact will lose heat, creating a negative lapse rate. So that is inversion. So a surface inversion occurs when the atmosphere at the Earth's surface is colder than the layer above it. Around sunset, the ground cools rapidly by radiating heat outwards, the terrestrial radiation. The air in contact with the ground also cools as a result of conduction, causing the lowest layer of the air to be cooler as compared to the higher layers. And that is the condition of surface inversion. So this is the aspect which happens near the ground surface, even in lower latitudes. Within the region of the tropics, subtropics, you will experience this. But then you have another condition, what is known as the upper air or subsidence inversion. Now, what is this subsidence inversion? So, this is first of all something which is observed in the region of the mid latitudes. Mid latitudes, especially during the winter months. That is when you observe this. Now, when we talk about mid latitudes, we are talking about 40 degree, 50 degree, 60 degree, north and south. That is the range or the region that we are talking about, right? 45 degree to 60 degree, north and south, or 65 degree as well, north and south. Now, in these areas during the winter months, we can always expect that the ground surface will be very, very cold and the air near the ground surface will also be cooler. Now, due to certain conditions, what we experience is that let's suppose the air from higher elevation, due to upper air circulation, let's suppose you have a sinking of air. The air tends to sink. As the air tends to sink, it is pushing itself into the region where the density is very high. Air density is maximum near the ground surface, we have already seen. So it is pushing itself into the region where the air is very dense. So naturally, this air will also start getting compressed. This air parcel will also start getting compressed. Anything when you compress it, heat is generated. So this compression of air will generate heat, will create a layer of warmer air. Again, you have warmer air and near the ground surface you have colder air. Again, a condition of inversion is attained. But this condition of inversion is attained why? Because of sinking air, because of subsidence of air. Otherwise, this inversion would not have existed. Hence the name subsidence inversion. This can occur for almost around 1 week to 15 days sometimes, because of as long as this subsidence of air continues, this subsidence inversion can always end up being in place. Oftentimes, factors like jet streams end up fueling this subsidence inversion. You had the very infamous case of 1952 London smog, where this subsidence inversion was created in the region of London, and all the fuel, all the burning of coal and all the fossil fuels, the emissions remained in the lower atmosphere for a long period of time. People would inhale that air, which was laden with carbon monoxide, and many of them experienced carbon monoxide poisoning, due to which there was significant amount of hospitalization and also large number of casualties. So that subsidence inversion can also be harmful, detrimental to health. Then we have another form of inversion, that is a frontal inversion. So frontal inversion is created again in the region of mid latitudes. Now, why does it get created? It is formed because in areas where you have from one region cold air, polar air which is coming in, let's suppose you have cold polar air. And on the other side, let's suppose you have the warm air which is coming in. Warm air. Now that zone of transition which is created between the cold and the warm air, that is what we refer to as a front. That entire zone of difference which is created between the property of cold air and warm air, it is known as a front. Cold air will be slightly compressed, less in volume. Warm air will be quite expansive, higher in volume because of greater amount of heat, greater amount of energy. So let's suppose this warm air is moving into the region of the cold air. Will it intermingle and live happily ever after? No. The warm air basically starts climbing on the cold air. Because the cold air is so dense, it won't be lifted easily upwards. So, as a consequence of that, you will observe that the warm air climbs over it. Warm air climbs over it. Now, this is the condition in this particular zone. If you consider, you have cold air at the bottom, warm air at top. So, that is again a condition of inversion. So, this is frequently observed in the mid-latitude areas, in the subpolar zones, where you have warm tropical air coming from 30 degrees, cold air coming from the poles. They interact. Warm air eventually will climb up because it is lighter, it is expansive, while cold air will hug the ground surface because it is heavier and condensed. That is again a kind of inversion. Then you have another kind of inversion, what we refer to as the valley inversion. This is observed in the mountain valleys during the night. So during the night, what happens is, if you consider the air temperature in the mountains and the valleys, the temperature above, here the air will be very cold on top of the mountains, whereas in the case of the valley, it will still have warmer air in comparison, right? Because the air density in the valley is higher, it will be able to retain more heat for a longer duration. Now, then when you have this cold air being heavier will tend to sink. Owing to gravitational force, cold air being the heavier one will tend to sink. It will place itself at the bottom of the valley, lifting the warm valley air above and on top. So this is again a condition of inversion. An inversion created because of the physiographic condition of the valley. That is why it is known as valley inversion. That is why at the valley bottom during nights, you will experience sudden lowering of temperature. That is why it is never advisable that when you have narrow valleys, in the case of broad valleys, mixture of air can happen. In the case where the valleys have entry and exit of air, air drainage can happen. But when you talk about those narrow valleys, where you have close mountains nearby and no passage of air, it gets very chilly at night. Crops get impacted, plants get impacted by the frost conditions. And that is absolutely disastrous. So that is basically all the conditions of inversion. So we have taken a look at different types of inversion. One is the aspect of when the surface becomes very, very cold, right? And the air in contact also has to become very cold. Then another is when you have the air which is falling from above, that gets compressed and gets warmed up, that is subsidence. Then when you have polar air interacting with warm tropical air, that is frontal. And then the conditions of valley. These are the various different types of temperature inversion, and the impact we have discussed: lack of air circulation, pollutants stay in the region for a longer period of time. In the case of valley, you can also have the condition where you have frost-like conditions impacting the plants in the region. So you can have multiple damaging impact. Now, UPSC had asked a question from this in the mains examination. That is, what is temperature inversion? Discuss the different types of temperature inversion and their impact. So in this, in the introduction, you could have simply written about the conditions of weather which create a negative lapse rate near the ground surface. is known as temperature inversion. This temperature inversion occurs because of certain climatic conditions, due to which it is classified into surface, subsidence, frontal and the valley inversion. Then with the help of the image you can describe it and talk about, if it is a 15-marker question, talk about the damaging impact also. Lack of vertical mixing, pollution, load will be much more and so on and so forth. And eventually you can conclude by saying that this condition of temperature inversion needs better prediction and much more awareness so that the public can also take their respective mitigation measures. Like that, you can conclude the answer. So that is basically the chapter or the topic of temperature inversion. If you have liked the content, put that in the comment section and don't forget to click on the like, share and the subscribe button. Do visit the other NCERT fundamental videos for other different subjects. Till we meet again, take care of yourself. Goodbye. Thank you.
NCERT books are unavoidable to crack the IAS exam. Not only is the content of these books authentic, but these books also help a civil services aspirant to build conceptual clarity. And most importantly, lots of questions in the civil services examination are directly asked from NCERT books. But the aspirants often find it difficult to cover these books, or worse, they even end up ignoring these books. We at Unacademy IAS English are going to make the reading and understanding of the NCERT books easier. We present NCERT Fundamentals course, a free initiative of Unacademy IAS English. What are the highlights of this program? Comprehensive coverage of the most relevant NCERT books for the civil services exam. Prelims and mains practice questions in each session to test your understanding of the fundamental concepts. This course begins from 12th of July every day at 6 p.m. right here on our YouTube channel. Subscribe to the channel now.